Assalamu alaikum, my name is Khizr Ali Khan and I'll be presenting our CAD summer presentation for our solar panel. First of all, our problem statement was that we had to design a solar panel that could be adjusted for the angles of the sun, and any person can just use a lever or something to adjust its angle and it stays in place. So that was the goal, to design it to have an adjustable angle to optimize energy efficiency. So the design approach was that I'd have basically a fixed base plate, mounted on some legs, and on that plate we'd have a movable solar panel plate. To adjust it, used worm gears because of their high gear ratio and the fact that they have self-locking feature that makes sure that the solar panel itself stays in place. Here are the drawing parts individually. Here's the base plate. The commands were just simply sketching and extruding the plate. Same thing for the base legs of the panel. I sketched them and then extruded them. For the panel itself, obviously I had sketched them, I had extruded it up. For these parts of the panel here, the panel itself, these were again sketching, extruding. Some of these longer lines that went across, used ribs for them. And for these smaller lines on each panel, I used linear pattern for them as well as the blue panels themselves to make the pattern on the whole solar panel. Here are the hinges that connect the solar panel to the base plate. For this, it was simply sketching, extruding, extruded out again. I drew a pattern here, made it here, created this hole with extruded cut, and used linear pattern to make two of them. Here's one of the components, one of the parts of the worm gear, as well as the connecting rod that connected through the hinges. Here was again simply sketching, extruding. I used the helical curve. I think it's visible here as well. Helical curve as well as the swept boss, um, to make one of the cuts here, the circular pattern to make it all around the gear, and the extruded cut was to make the hole inside the gear to place this shaft. Here down at the bottom is the other part of the gear that will mesh with that first one. Again, sketching, extruding, I used the helical pattern and the swept boss to create that pattern. Was some more extruding here, and this handle here was made with the revolve boss. Here's the final assembly. The mating commands that I used were concentricity, which was to align these shafts and the holes coincident to make sure that the hinges and multiple parts lined up correctly. I used the distance command to make sure that the distance from this worm gear to this end was constant from here to here, so as to make sure that this was in place and so I could actually rotate this crank. Angle lock was to make sure the solar panel can go from 0 to 90, no more than that. And gear mechanical was to create the ratio between these two gears. So how many times I rotate this crank would dictate how much this would rotate in turn. So yeah, the mechanism for the angle adjustment was primarily done by adjusting those gear ratios relative to the teeth on both of the gear parts in the set. And for conclusion, it was this whole objective was to make sure that we can make the solar panels energy efficient by adjusting the angle according to the sun, and so we can further use this, real life applications. Thank you, and I would also like to my apologies, the video cut out because I was switching tabs. Here's the actual assembly. I'd like to show this as well. Here is the crank that you can use to rotate the solar panel, and the panel rotates as well. You can adjust it to whatever angle you want. And the fact that these are worm gears means that I can rotate this way, this gear, this crank, to make this gear move, but this gear will not be able to move this back. So this also acts as a self-locking mechanism, making sure that whatever height or angle I adjust the solar panel to, it'll stay at that angle. And the rest of the assembly is there, the legs, the base plate. Here are the hinges. There is one hinge for each uh, part like this. One of the hinges will go on the panel, one will go on the plate, and I've created three sets. The rest is, we have the panel here, we have the ribs that went across the upper part, the extrusions, the linear pattern that was used to make all of them. There's a clear glass sheet on it as well, which maybe isn't as visible, but that is the primary assembly for this panel. Thank you.